Good evening, student. So continue our series of one day, one circuit. I am today discussing this maximum power transfer theorem. Okay. So we know any two terminal linear network. So this is my two terminal linear network. Okay. So here we have a load RL. So we know from Thevenin theorem that any two-terminal linear network can be replaced by a Thevenin equivalent, which consists of a voltage source V Thevenin and in series a resistance R Thevenin. Okay, so these two networks are now equivalent. Now, what does maximum power transfer theorem says? It says that in order to maximize the power in RL, okay, the Thevenin resistance should be equal to, or the load resistance should be equal to R Thevenin. Okay, if I see the R Thevenin across this RL, okay, that should be equal to R Thevenin. Okay, so let us prove this theorem. So first I need to calculate the power in this resistance. So if I calculate the power, so power is given by I square Rn, and I we know is given by V Thevenin upon in the circuit total resistance is R Thevenin plus RL. So this become current. Okay. Now if I want power, so power will be V Thevenin square R Thevenin plus RL square into RL. Okay. Now, in order to prove that this power is maximum, okay, for R equal to RL equal to R Thevenin, let us differentiate this expression of power. So, if I differentiate power with respect to RL, I'll get V Thevenin square. Okay, if I differentiate RL by R Thevenin plus RL square, so this will give me R Thevenin plus RL 4. Okay, so now I need to differentiate this one. So this will give me R Thevenin plus RL square. RL will become 1 minus. Okay, now if I differentiate this expression, so this will give me what 2. RL is already there. If I differentiate this one, this will give me R Thevenin plus RL. Okay, and this should be equals to 0, and this will give me the condition of maximum power transfer. So if I solve it further, okay, this will give me what? This will give me R Thevenin plus RL square minus 2 RL R Thevenin plus RL equals to 0. If I solve it further, this will give me R Thevenin plus RL minus 2 RL equals to 0, and this gives me RL equals to R Thevenin. Okay, so in order to maximize the power, my load resistance should be equal to the Thevenin resistance. Okay, now if I want to calculate maximum power, okay, so if I want to calculate what is the value of maximum power, so I have this equivalent circuit plus minus V Thevenin, and I have this R Thevenin. Okay, and again now this RL will become equals to R Thevenin for maximum power transfer, and the value of P max will be, okay, I square R Thevenin, and I square this time it become V Thevenin square. Okay, R Thevenin 2 R Thevenin, that means 4 R Thevenin square into R Thevenin. So this will cancel out. So the formula for P max will be V Thevenin square upon 4 R Thevenin. Okay. Now let us understand this question with the help of a problem. Okay. So I have been given one circuit, 12 volt. Then we have this 12 ohm resistance here, 6 ohm resistance, 3 ohm resistance here. Then we have one more current source here, 2 ampere. Okay. And we have one more resistance, 2 m. Okay. And this is my RL. Okay. Now, in this question, they're asking what is the value of RL so that the power transfer should become maximum. Okay. So we know the for maximum power transfer, our RL should be equal to R Thevenin. Okay. Now let us calculate R Thevenin. So we know how can we calculate R Thevenin. In order to calculate R Thevenin, okay, seen by the load, I need to open this load and all the sources should be deactivated. Okay. So sources deactivation means if there is a voltage source, I need to replace this by a I need to short this resistance. Okay. And current source need to be open. So if I open this current source, now whatever resistance seen by this terminal will be your R Thevenin. Okay. Now if I calculate R Thevenin, so we can see these two resistors are in parallel. So 6 ohm resistance is parallel to 12 ohm, and then these two resistors are in series with these equivalent of these two resistance. So the total resistance will become 6 into 12 upon 18 plus 5. So this become 3, so this become 4, total become 9 ohm. Okay. So when my RL is equal to R Thevenin equals to 9 ohm, in that case the maximum power. Now if I want to calculate what is the value of maximum power, I also need to calculate the VThevenin. Okay. And we know how can we calculate VThevenin. So if I want to calculate VThevenin, this is 12 volt battery, and here we have a 2 ampere current source. So if I want to calculate the V Thevenin, so V Thevenin is nothing, that is the open voltage, so open voltage across this terminal. Okay, say this is VL or V open will be equals to my V Thevenin. Okay, now there are many methods we have discussed to calculate voltage in a circuit. Okay, so I am solving this by a superposition principle. And superposition principle, what we do, we take one source at a time. Okay, so if I want to calculate uh, open circuit voltage here due to 12 volt battery, then I need to deactivate this current source. And similarly, if I want to calculate voltage here due to this source, I need to deactivate the voltage source. Okay, so let us, so total voltage across this V open, okay, due to this 12 volt battery, okay, and due to this 2 ampere current source, okay, will give me VThevenin. So V open or equal to VThevenin, okay, and this will be due to 2 ampere current. Okay, so let us first calculate the voltage V12 due to this battery, okay, across here. So let us say this is V1 or V2, okay, because here 12 ohm resistance is there, so symbol may be confusing. So now I'm calculating due to 12 volt battery, okay, V1. So So in order to calculate V1, I need to deactivate this current source. That means this will become open. Now this V open, okay, whatever voltage come here, that will be my V1. So from here circuit, you can see this current will start here, okay, and current will go here. Now here this circuit is open, so no current will flow in this portion of the circuit, okay. So there is no voltage drop here. That means this terminal and this terminal are have the same potential because there is no voltage drop, no current is flowing through the circuit. This potential, this terminal is the same. So whatever voltage will be here, okay, that will be my V1. So if I calculate the voltage across 12 ohm, that is simple circuit. Okay, I can apply KVL or I can calculate the total current. Total current will be, so total current will be what? Total current will be the current flowing through 12 ohm resistance will be 12 volts. Okay, divided by total resistance. So no current flowing here. The total resistance will be 18. Okay, so my current will become, say this is 2 by 3 ampere. Okay, now I want to calculate the resistance V1 here, so that will be V across 12 volt, okay, 12 ohm resistance. That will be 12 2 by 3 current into resistance. So this become 4, so this become my 8 volts, okay. So this is my V1. So my V1 is now 12 volts, sorry 8 volts, okay. Now let me calculate V2. So V1 is 8 volt, okay. Now let me calculate voltage due to this current source. So this is 2 ampere current source, okay. Now I need to short this source. So now I need to calculate this V1. That means I need to calculate this voltage, okay, across this current source. So 2 ampere current will go from here. Since this circuit is open here, so no current will flow in this portion. So this current will go here, 2 ampere current will flow here. Okay, say this, I need to measure this. Now this circuit, so this is my V2. Okay. Now this current will be distributed here in a parallel circuit. So if I want to calculate this voltage, okay, I need to calculate what is the voltage here. Okay. So if I calculate voltage drop across 12 ohm, so I need to calculate the first the current. So current in this case will be, okay, I can calculate the current by current division rule. So current division rule says total current, okay, will be, if I want to calculate current here, I take the resistance of this one 6 upon total resistance, that is 18. This again comes out what 1 3 2 by 3 ampere, okay, and the voltage across this 12 ohm, okay, 12 ohm will be, say this is V, okay. So this V will be now V through resistance, okay, V ohm, V through resistance will be my what 2 by 3 into 12. Again this comes out 8 volts, okay, but I need this V2 voltage, okay, because this voltage and here there is a drop, okay. So if I apply, so this is my 8 volts, okay, current is flowing here. Similarly this current is flowing here, so this become 2 into 3 6 volts, okay. Now I want to calculate, okay, V2. So I can easily find out what is V2. So whatever voltage here, the drop will be this one, and I'll get this voltage. The voltage will come here. So I can write my V2 minus V omega is equal to 6 volt. So V2 V omega is 8 volt equals to 6 volt. Okay, 6. And this will give me V2 equals to 8 plus 6, 14 volts. Okay. Now if I calculate total V open, that is equal to V Thevenin. So V Thevenin will be equals to V open, and that will be equals to 8 V1 plus V2. Okay, 8 plus 14 volts equal to 22 volts. Okay, so this is the value of V Thevenin. Now for maximum power, okay, I need to calculate P max. P max is nothing, that is V Thevenin square upon 4 RL or R Thevenin. and B Thevenin square is 22 square, 4 R Thevenin is 9. Okay, so if I solve this one, I should get the value 13.4 watts. Okay, so this, if I solve this one, this will give me 13.4 watt is the maximum power across RL. Okay, I hope you understand the theorem. Okay, thank you very much.